All right, friends and neighbors, welcome back. We are tackling Chapter 6 in CCNA Volume 2, Implementing Switchport Security, and we'll see exactly what that means in terms of modes and violations. So here we go. So in this video, as always, the key topics. Our exam section is security. So, these are some of the security fundamentals, and we're starting at Layer 2. And so we're going to be configuring Layer 2 security features, and in particular, port security. Now, there are other things that you can do on ports, but right now we are tackling port security in terms of what happens when you have a violation in traffic. So this is just part of the exam section for Layer 2 security features. And then we'll polish up with the "Do I know this already?" questions. So our key topics in this particular video: summary of port security concepts and our checklist, right? What do you go down through to figure out what you want to do? And then we'll do a couple of demos. In the chapter, there are several configuration examples, and we'll do a couple of those here as far as demos go. And then we'll talk a little bit about what happens when you implement a particular mode, and then you say, here is a violation, what happens when that happens? Now, the basic idea is this. You know what device or devices are supposed to be cabled to a port or ports, right? And by that, I mean, you know the MAC address and probably the IP address, although for this video, the important thing is the MAC address. So you should use port security to protect and ensure that that connection stays up and that nobody uses that as a vector for attack. So if you said on a particular port, I'm only supposed to have a particular MAC address, or I'm only supposed to have a certain number of MAC addresses, those are the two common ones, it reduces your exposure to attack. Now remember, if we go back to how switches operate, the source address table population, how it works, right? A node generates traffic, and what does the switch do? Well, it does a couple things. It looks at the frame coming in and says, aha, I see your source MAC address. Do I already have you in my source address table or my MAC address table? So that's one thing it does. Another thing that it does is it says, all right, where are you going? Do I know where that destination is? And then it makes a forwarding decision based on that. And of course, there's the CRC as well. Well, port security examines the exact same sort of thing. It says, all right, I'm going to look at your source MAC. Are you supposed to be here, or have you created some other violation? So the switch says, not only am I trying to learn who you are, I'm trying to see if you've broken any rules. Now, it's not limited to directly connected devices. If you take a look at the graphic, sort of above me here, PC1 and PC0 are directly connected to switches, but PC1 gets to PC0 through both switches. And so there's nothing at all that says I can't have a rule on G0/2 about PC1. So even though PC1 is not connected to that switch directly, you can certainly be monitoring the traffic. So what happens when there's a violation, right? A rule gets broken of some kind. Well, the switch just might say, hey, listen, I saw this thing over here. The switch might say, I saw this thing over here and I'm going to stop its traffic. Or the switch may say, I saw this thing over here and I'm killing off the port. I'm shutting it down. Now, our port security options. Remember that we're operating from a few basic principles. We're not talking about any advanced features like the snooping or anything else. This is really a focus on the port security options itself. So we're going to base these options on a few things that we look at. The maximum number of MAC addresses that appear on a particular port. The per port security, right? So if you said I've got 24 port switch and I've got each node or a node connected to each port, you know exactly what their MAC addresses are. So I know who's supposed to be there and what MAC addresses I'm going to examine. So in addition to populating my source address table, I might say, listen, are you supposed to be on this particular port? And then if I see something new that's not in my registry, right, I might say, all right, did this cause a problem? Did you break the rules in some way? Now the MAC address limits, let's say I say on a particular port between two switches, my maximum number is 24. Well, I might say, listen, I want to learn those MAC addresses and then automatically put them in my rules, or I might statically define them. Now, it depends a little bit on which iOS version you have and what flavor of iOS you have. So in more modern implementations, because manual configuration is a pain, you can do something called sticky secure MAC addresses. And it's just simply saying, listen, I want you to learn these MAC addresses that are out there and we'll apply the port security rules to those MAC addresses. But again, it depends a little bit on which version you have and which OS flavor. Now, it doesn't matter really what kind of port you're talking about. They can be on access ports, right? Ports that are connected to a particular node. They can be on trunk ports. Trunk lines run between switches. You can have voice lines or ether channel ports. So remember that voice lines might have that voice VLAN, so multiple VLANs on the same port, even though they're not trunks. And then ether channel ports, that's what we did the aggregation thing. Now, what you have to remember, too, is that you're setting up this security. You have to understand what is the nature of your topology. And the big thing here is that you have to remember when you're looking at links between switches, whether they're trunks or not, you're going to be dealing with a lot more MAC addresses than just a port connected to a particular device. So we have a couple of steps, our checklist here. You're going to determine what kind of port you're going to deal with, right? So a lot of times the default is dynamic. And you can do that, but sometimes it's when you're setting up security and when you're setting up your nodes, we move away from dynamic. So you choose switchport mode access or switchport mode trunk, and then we'll enable switchport port security. And then you decide what you're going to do with your port security. So we've got the rules that you want to apply and then the violation type that you're going to apply. So the two things that we're going to do in the demo today, we'll do a max number and then we'll do a MAC address. And then we'll determine the violation type for that. And we'll see what that means here in a minute with our options. Now the switchport port security MAC address sticky, that's when we want to learn the MAC addresses because typing them all in by hand is a pain. So I'm just going to do one MAC address in the demo. Now one detail that the chapter makes note of is that MAC addresses learned via sticky are not retained. So you have to make sure those are saved outside of the normal processes. Okay, let's do a demo. So here's our topology, and I'm just going to ping around a little bit. See that I did a little bit of pinging already, but I'm going to ping from the bottom switch to the top switch, and so we're going to go to 5 and 6 from all of my nodes. Now, all that I'm doing really here is populating the source address table, but really I'm also showing you that we have full connectivity. And everything works. Now, the only thing that I'm not going to do is ping from our 1.4 because I'm going to use that as my rule breaker later on. Okay, well, let's take a look at what we have as far as a connection goes. I've got G0/2 up here. So I'm going to go to my switch then, and I'm going to go to that particular interface in G0/2. Now, as we can see here, to get us started, we need the switchport command. Expand this a little bit. And there is our port security. So the first thing that I'll do is I'll say switchport mode access, right? And all that we're doing is specifying. Now, this is between switches. So in between switches, I might say, well, I'm going to have, actually, I'm going to change this to trunk because that'll be a more interesting demo. And now what I'm going to do is I'm going to say switchport port security. Now that if I just hit enter here, this enables port security. But if I take a look at my options, what do I want to do here? Well, if I take a look at what's going on, I'm going to say, well, I have a whole bunch of PCs down here. So the port security that I'm going to watch for in this particular case is a maximum. And that is a maximum number of MAC addresses. So you can see there's an actual limit to the number of MAC addresses that might be downstream of the port. And what I'm going to do is set this to 3. Okay. Now, as soon as we go amber here, and actually maybe what I'll do is we will, to speed up our process, I'm going to say to both sides your trunks. So int G0/2, oops, and I'll say switchport mode trunk here as well. Oh, I forgot this is an older version of the iOS, so I'm going to say switchport encapsulation. Oh, switchport trunk encapsulation .1Q. And then we'll say switchport mode trunk. Okay, so that should straighten us out. Now, as you recall, all 3 of these could ping. If we remember right, when these machines are communicating, there'll actually be spanning tree messages that go back and forth here as well. So the switch also has a MAC address, so you have to be aware of that. So when you're setting up your port security, if your network devices themselves are generating traffic, that might create a problem for you. Now we'll also do our simulation just so we can see the traffic that's flying. So the first up here is I'll ping .6, that's going up top there. And that looks like it goes through. And we'll ping .6 from here as well. So that looks like it goes through. We'll ping .6 from, let's see, this is .3. Did I not ping from this guy before? I thought I did. All right, so that traffic is going up there. So that looks pretty good. And then finally, we'll do our last one. Now it doesn't look like our last machine made it through. Now all that I did was enable port security. Now if we take a look at this message right here, line protocol on interface gig 02 changed to down. Well, why did that happen? Well, all I did was enable port security. So let's do this. We're going to say show port security G0/2. Oh, interface. And we can see that it is shut down and it is in secure shutdown. So the mode, as we'll see here in a minute, the mode or the violation type was to shut down this port. So if I say instead int G0/2, switchport port security, now what are my options? If I say violation, what do we do? Well, what mode we were in when I just enabled port security was shutdown. But if we just do protect, right? Now what this would have done would be to just send a message about it. But if I did restrict, then it says, well, I'm only going to allow things that don't break my rules. Now, one of the problems with port security is that even though I just did that, we can see that the link is still down. So to recover from an error disabled, you need to do a shutdown on the particular port and then a no shutdown on the port, and that brings it back up. So if you are futzing around with port security and you have an error disabled or a security shutdown port, the way to recover is to shut it down and then bring it back up again. So we'll just wait for this to come back up. Remember that it's 30 seconds for spanning tree. So where nobody was able to communicate before, we'll try this again. Remember that the violation pops in when we go past 3. Okay, so are these other nodes still able to communicate? They are, but this one is not. And the reason for that is that we broke the violation. So we've got one MAC address for the switch, one for .4, one for .3, and then .1 and 2 were left out in the cold because they were both greater than 3. Now the mode, the violation mode here is that we restricted the traffic. So the traffic is restricted to just those MAC addresses. Now, if these nodes stop communicating and the MAC addresses time out, then other MAC addresses will be allowed. But this is a way to restrict the traffic to a subset of your overall nodes. Now you'll notice that I have a MAC address right here. So what I'm going to do here is I'm going to do a different rule. Now on this lower switch, I'm going to say Switchport port security. One of my options, I'm going to say I'm going to restrict this to a particular MAC address. Let's see if my paste worked. There we go. All right. So this is the oops, I forgot to do port security. Port security. So we're going to now restrict this to a particular MAC address. And what is the violation type? We just want to restrict. We don't want to shut it down. So I'm going to say Switchport port security. Our violation type will be to restrict. Now what's the impact of this? So now we have to recover. What's the impact of this? Well, coming from switch 1 to switch 2 on our port up here, we've said we're restricted to a maximum of 3 MAC addresses. And on the opposite side, this one here is that I'm restricting the traffic to just this particular node here, my server. So let's see what happens once our port comes back up again. What should happen is that I should still be able to send traffic from a couple of nodes down here, but the only one that will be able to communicate is 1.5, which is my server. So let's see what happens. So all of a sudden 1.6 is not able to communicate. And let's do the simulation for this. All right, so there's our spanning tree traffic that shows that the switches are communicating and consuming one of those MAC addresses. All right, let's try 1.6 again. And the question is, where does it die? So it goes all the way up, gets to 6, comes back, and goes down here to our switch 1, and switch 1 says, you are not the right MAC address. So now, let's take a look at what happens when we do to .5. Now in going to .5, again, there's our ARP traffic going all the way up. 1.5 comes back, and is it able to answer? And it is. So the ICMP goes and is allowed to continue. All right, so what did we see here in this demo? We saw first that I had a MAC address limit here on switch 0. And then we determined that, well, instead of shutting down the port, we want to just restrict ports to that particular number of MAC addresses. So that also gave us an opportunity to see how to recover an error-disabled or a secure shutdown port. And then we did another rule down here, and we restricted the traffic to this particular MAC address. And again said, we don't want to shut down the port on violation. We want to just restrict access to nodes that are not this particular MAC address. And that might be a perfectly valid use of port security when A, you're dealing with access ports, or B, you're trying to protect an asset. So verification of your rules. We did the show port security command so you can see exactly what's going on a particular port. But when you're trying to learn or understand what your security should be, remember that we've got show MAC address table, but also show MAC address table dynamic, show MAC address table static if there are statically configured devices, and then also show MAC address table secure. That is anything that's a MAC address and tied to your security. So you can take a look at both the show switchport port security or I'm sorry, show port security interface and then whatever it is, and it'll tell you what's been configured but also what's been happening, including the number of violations, or you can look at your show MAC address table to give you some idea what should be happening. All right, so now that you've seen these in action, let's think about those modes that we saw. All right, so we know we've got our rules. We set our rules up. In this case, for the demo, we did the maximum number of MAC addresses, and then the MAC addresses that are connected to a particular port, or the ones that we want to use or that we want to apply security for. By the way, we also saw that we could recover a shutdown port, but we could also say, I'm going to set up rules on a switch that is not directly connected to those nodes. So what happens when we break the rules? Well, we've got 3 violation modes that we can use. We saw that there was protect, and then restrict and shutdown. So that's in the table to the side of me here, that side. And the difference is in the response. So if it's just protect, that means you're going to generate a log message or a syslog message that says, hey, there was this violation, and that's it. Restriction says I'm going to send that message, right, to my syslogger, or, well, and I'm going to restrict traffic that doesn't fit my rules. In other words, I'm going to allow the nodes that are valid and disallow the nodes that are not valid. And then lastly, the most secure mode you might have is the shutdown, which says I'm going to let you know about it. I'm going to send the messages, right? So we're going to discard the traffic, we're going to send the messages to the logging server, and we're going to kill the port off entirely. Now, port security shutdown mode. What happens if you're shut down? So the actual name of the security state is secure shutdown. So you saw that in the show port security interface command. Now the state is actually called err-disabled or error-disabled. And in that case, incoming and outgoing traffic is prevented. Now, the way that you recover is to first fix the problem. Why was there a violation, right? Why did your port security react the way that it did? So you got to fix that. And then what you do is, as you saw in the demonstration, right, we're going to shut down the port and then bring it back. Now, more recent versions of the iOS also have automatic recovery. So you can do the err-disabled or the error-disabled recovery cause violation. So if you have this violation, it can automatically recover. But not all iOSs have that. So this is just a reminder of your modes of operation and what causes the, and this is what you can set up to respond to that. Now, one other note about this is that troubleshooting can be challenging as the port still works, kinda. So why is it challenging? Well, the first thing is that some stuff works and some stuff doesn't. So if somebody sets up port security and all of a sudden you've got some nodes that can connect and others don't, in one case, the port security may have been set up correctly, and so you've got some of your nodes that can connect and some of the nodes that can't connect, and that would be by design. It might be that port security is set up incorrectly, in which case you've got the wrong nodes that are being blocked maybe, and the wrong nodes that are being allowed. So you have to sort of get to the root cause of the problem, right? Why did this thing break down, and are our rules correct? So that might mean tracing down MAC addresses, taking a look at capture traffic, and so on. And remembering that you can do the show port security and show MAC address table commands. Do you know this already? Which of the following is required when configuring port security with sticky learning? Well, the first thing, as you saw, I forgot to do it. You've got to enable Switchport port security first, and then you can do whatever your options are. Number 2, a Cisco Catalyst switch connects to what should be individual user PCs. So those would be access ports, right? Each port has the same port security configuration, configured as follows. So there's the range command, everybody's been made an access, port security has been turned on, and then Switchport port security MAC address sticky has been enabled as well. So that means I'm going to learn whatever MAC address is there. Which of the following answers describes the result of the port security configuration created by these commands? Choose 2. That was B and D, switch traffic is prevented, and it will not save addresses. Okay, so if you're in violation of the MAC addresses, then your traffic will be prevented. And as you saw, depending on which iOS version you're dealing with, that might actually be shut down. In the case of sticky, right, we have to also remember that those MAC addresses are not retained, right? The switch learned them, And in the same way that the switch sat does not save that stuff, neither will the sticky MAC addresses be saved. All right, question number 3. Which of the following commands list the MAC address table entries for MAC addresses configured by port security? There are 2 commands that will do it. B and C, show MAC address table and show MAC address table static. Now, the confusing part about that is that if you did sticky, they're kind of learned, but if you set up MAC addresses configured by port security, then they would have been static. So you could see them in a MAC address table command or in the static configuration. Question number 4, the show port security interface F0/1 command lists the port status of secure shutdown. Which of the following answers must be true about the interface at that time? Well, the state will be err-disabled or error-disabled. And of course, the security state is secure shutdown. So we saw that when we were recovering. Question number 5, a switch's port gig 01 has been correctly enabled with port security. The configuration sets the violation mode to restrict. So this is not shutdown and this is not notify, right? A frame that violates the port security policy enters the interface, followed by a frame that does not. Which of the following answers correctly describe what happens in this scenario? So there's a couple of things, right? One is that a log message will be generated. A log message is generated for all of the modes, and the violation counter will be increased by 1 because one MAC address violated and the other one did not. All right, the Chapter 7 look ahead, implementing DHCP. This is very exciting. We're getting into services, and then we'll have all these follow-up topics that go along with those services. So we'll talk about IP parameters for client operating systems. Most notably, those will be IP address and mask, DNS, and then the gateway. There are some mandatory settings in order to be fully functional on the network, and then we'll talk about some of the optional ones. So the 2 big topics will be DHCP and DNS within our networks. That's the dynamic host configuration protocol and the domain name system. Critical infrastructure. And then, of course, we'll do configuring and verifying DHCP clients, but also relay, as routers act as a relay agent very commonly. All right, this has been port security modes and violations. What can you do to set things up, and what happens when somebody breaks the rules in your port security? So what is a violation and what is the result? Modes of operation: protect, restrict, shutdown, and then, of course, our state: error-disabled or secure shutdown. All right, like and subscribe to take on DHCP and DNS. May those packets always reach their destinations, unless you violated port security. And hey, this is CCNA. We're working through the security topics. You can do this.